Welcome to our project designing a quick-acting clamp in Solidworks in DFT 170 Engineering Graphics in Cape Fear Community College, instructed by Dr. Hans Chapman in the fall semester of 2024, presented by Alex White, Ben Flores, and Thomas Cowan. Here are the reference models that we used as a guideline to figure out the dimensions and materials used for modeling and assembling the quick-acting clamp. Given how we weren't provided measurements or dimensions, we used real life and intuition to figure out what would be the best material and dimensions for it. These are the hand sketches that we drew in order to get a rough estimate of what we needed to model in SolidWorks. And given how we weren't provided any information of the dimensions, we had to make those up along the way.
These are the parts for the clamp. This is the main body part here. This was made via sketching, extruding, and then mirroring holes onto the piece, and also chamfering the bottom part here. The next piece is the bolt. This was created via sketching and then revolving. Its diameter is 1.25 inches. This bolt is also 1.25 inches and has a different has a hole in the middle. This bolt is also 1.25 on the outside. The only difference is the diameter of the hole here for the bolt. These were all created the same way, just instead with the extended cut in the middle circle. And then finally we have the threaded crank. This was sketched and then also revolved, and then for this we used the threaded tool in SolidWorks. And this is the fully assembled clamp. As you can see, all the pieces are here together. The main body, the bolts, and then the threaded crank. The only piece that it wasn't included was this rectangular piece, which is simply just a rectangular piece with a hole in it. And that is it for the parts.
Hey, this is Alex, and I am showing you a drawing document at the bottom left. That is the front view. Even though that isn't the front of the device, you have an isometric at the top right, and at the bottom right of the drawing document, you have your logo and all your information that was needed. In this slide, we ran a simulation and put weight at the front of the clamp, which simulated it being pressed down. As you can see, there are deformations on the part that goes straight into the table. Here is an animation of our clamp in action, and notice that as you turn the crank, it pulls and lowers the weight at the front, which presses things down onto a table. For closing remarks, we were given examples of an isometric clamp, and we had to go online and sketch different parts for this. After that, we 3D modeled each of the different components and put it into assembly. We then had a drawing documentation of the whole entire clamp. After that, we did simulation of stress tests on the clamp, and we showed an animation at the very end. Thank you for watching.